intro. So it's good to be back for the second episode after our, hiatus in the first one. I do see a lot of familiar faces who have been here since the first episode. So welcome all. And for those of you who are joining new for this session, again welcome. So happy to have you as part of a wider series that we have planned across the coming months. Guys, in the session today, just to reiterate, I will be using the word Datorama or Marketing Cloud Intelligence synonymously. Just to give some clarity, Salesforce has been working hard to rebrand Datorama into Marketing Cloud Intelligence or MCI. So if I do use Datorama, it's out of habit, but just rest assured, I'm referring to the same platform to avoid any confusion there. So coming to the topic of the day, right, which is data blending or data harmonization, as we love to call it internally. So there's a simple question. So with the outcome, with the, what's the principle of the topic today? So why do we need blending or harmonization for that matter? So what's the reason for that? So if you think deeply into it, right, there's actually a simple answer for it. Simple answer is, it's in a very generic manner. If you want to explain, it's like, to get a complete picture of, of and all the insights of the story that you're trying to bring out of your data. And to do that, harmonization of blending is very important. So imagine this way. So say your insights that you are having in the data is spread across multiple different data sources in bits and pieces. Now you can't really create multiple different dashboard pages and tabs for your reporting partner, right? It's not effective in terms of getting actionable insights. So it's very important, for harmonization of all the data points for seamless flow of insights. That's very important here. And that's where the entire concept of this harmonization comes. And if you have to go a bit deep, right, in today's environment, I would say it's even more relevant. The digital marketing environment has been going through rapid and dynamic evolution. So what was 20 to 30 different sources of data or publishers, like data providers 6 years back, has boomed into 500 plus publishers. And it's gone are the days where there's one data set which was able to give all your insights. Now you need to go through, scroll through multiple of those providers to get actionable insights. Let's take this as an example, which is here. It's like a typical, very well established cross-channel dashboard that has harmonized data in it. Now let's take, you have a programmatic or DSP data coming from AppNexus. It might be served via DCM, which you're pulling from a data lake. Then it has combining analytics data also that's being pulled from the client's website. Now imagine add into this a third-party ad verification data via IAS or Moat. Now for one particular campaign, you have insights coming in or data coming in from 3 or 4 or more, in some cases even more than 5 different data sources. That's where harmonization is very important. If harmonization is not done in this instance, what happens is you just have a bunch of insights that spread across multiple data sources that is neither actionable or neither fruitful in terms of efficiency of, in what you're trying to achieve out of your reporting itself. So that's where the entire thing of harmonization comes. So now that you know what's happening here, right? Before, I know everyone wants to get their hands dirty and try to see us going deep into it. But before going there, I would like to, quickly take time to recap what has happened in episode 1, so that people who are new can get coherence of what has happened, and also people who are old can get a flow of what has been done, so that they can readily get attached to themselves to what we are trying to achieve today in the session. So if you recall, in episode 1, the mantra was very simple: data preparation, data ingestion, and finally data validation. So let's visualize that mantra in terms of what was being done. So in terms of data preparation, you might recall there was a demo data set we created with that had all the data features in it. Like, I mean, that are all the endpoints in it, like campaign, advertiser, site placement, etc. And by understanding the Datorama's data model, the entity relationship there, one to one, one to many, many to many, etc. We, through this architectures of what Datorama set up, we try to understand our data set So based on that, we created a pivot. We understood how the different dimensions interact with each other and etc. So once we understood this, we went back, we ingested the same data stream. Yeah, I mean the same data into a data stream, which you see over here. If you recall, we created two data streams, right? One was wrong and right. And in the right data stream, these are the mappings that were done and all the fields there were mapped here, and then it was created, and that's the data stream over here. So once this was created in a pivot, we also validated the data. We compared the numbers across, the raw files, and we were able to make sure, at different data levels of the data, the numbers were matching. So that was done. And if you recall, I also said what happens if you actually don't follow the naming, I mean, the proper data model, right? In the wrong data stream, we did get an error saying if one placement had multiple campaigns associated with, there's an aggregation error happens. Even that was thrown out. If you don't follow the model that was given to you, what happens? We also went through that. So this is what we covered in the earlier session. So now let's go to the next one. So now let's go to the topic itself. So our topic here is blending or harmonization of the data, right? So important thing, again, when we are going beyond this, urge you all to, go through these articles within the Salesforce help section. They have like tremendous wealth of, articles and technical know-hows of every single feature within Datorama is explained over here. Some of them, when you don't know, you might be overwhelmed with the option that has been given within the platform, and because it's unknown to you, you might see it's like a complicated or too technical to implement. But these articles do help a lot, and if you do know the process, you'll come to the conclusion it's like much more simpler and it's much more easier to implement, and with understanding the technicality of what is happening there. So these things will help you, and all the topics that I cover today are well established and defined over here, with also the use cases. Of course, I will be picking the most prominent and most useful ones, that covers the majority of the factors and processes. And of course, you into account, because, we do have time constraints here. But I urge you to, go through these ones. They will definitely help you. Okay, now coming back to, blending of our data, right? Here's the thing. Now I explained to you why we require it. Now, in terms of blending itself, right? Through years of experience, I can tell you one thing. Which is actually not explicitly stated in the articles, but I can say from experience itself, Datorama has actually two ways of blending the data. I would say grossly, harmonizing or blending, which you can call it. It's actually it can be broadly done in two ways. One, you can call it as the passive blending. The other is called the active blending. So first, I'll take you through passive blending. I'll go through the process, and then I'll take you through the active blending, which contains parent-child and fusion processes, which are for this session today. So in passive blending, right, it's kind of like very simple. You're not implementing any additional process or steps, after ingesting your data. The way passive blending happens is you leverage the power of Datorama's data model. So if you understand what's happening in Datorama's data model, right, you're leveraging that connection to make the blending or harmonization happen to you in the backend for you directly itself. So what I mean by that is, you do know Datorama as a data model, right? And they're like a fixed set of entities that are defined in the system. You're making use of these defined entities to make the blending for you. So I believe if I go and create the data stream for you and show the process, right, it will be much easier. You can be able to visualize it. So let's start, creating the process. And as usual, I have created data sets for the process today. So let me take you through the data set itself. So we have two data sets, passive blending 1 and 2. So the use case, you can assume it this way. So you have a DSP, a programmatic data coming in 1, and there's the ad server coming in 2. So let's open both of them. First of all, I'm assuming, let me just do one thing. And also, I don't want to make the mistake from last time. I hope, yeah, I'm sharing my screen. Yeah, perfect, cool. Okay, so now coming back to the data set. Now you see here, this the DSP data set and the ad server data set, right? So between these two data sets, it's simple. The use case is, you're getting impressions here. Now, maybe the client says, for me, the source of truth is always the clicks. So you need, and it needs to come from ad server, and I don't want to look at DSP. In that situation, you're getting the data from two different sources now. So now what is happening here is you have the date, placement, and impressions in one file and clicks in another file. Between both of them, you'll notice one thing. The names are the same for both of them. Of course, the keys are different, which we don't have to worry in passive learning. The names are the same for both of them. We are leveraging this, to make the connection for us. So let's start, ingesting these files. So I'll create a new one, start creating the data stream. So as usual, we use total connect. Of course, this works for all the APIs also. So let's call this as, DSP. It's called P building. And let's put in the file. And that's it next. So, you'll get a preview, and then you can go to the next. And if you recall, since we are using the standard conventions for our column names, all the mapping should be done directly for us. I don't have to worry about doing separate mapping. Let's hope it's done. Yeah, it's perfectly done. So all I have to do is create it now. So let's create the stream. Once this is done, what I'll do is I'll just go and create a second data stream for the ad server data. So this is the passive blending ad server data, same. And preview is there. We'll go to the next, and as usual, the mapping should be done for us. And let's see. So once this one is done, all the mapping is good, and I'll create the data stream. Perfect. So let's see. This one is done, and let's see this one. Perfect. This is also done. So let's create a pivot now. In the pivot, what I will do now is I will bring in both these data streams, both these blended data streams. D is not required. In the filter at the moment, it's because I clicked on that data stream, it's just putting in that filter. So I'll just add in ad server passive also, save, and I'll bring in clicks. Done. So now let's bring in media by name, which is this, the thing that we mapped. Apply over here, and side, I'll also want to show the mapping to you. So if you notice what's happening, both these data streams were actually, if you notice, both these data streams are separate entities. They are two different data tables, but within the table, because the names were the same, and because in both the data streams we mapped to media by name. What I mean by this, if you go to these data stream and mapping, the field in the file was mapped to media by name. This is basically the placement name that we mapped from the file. If you notice both, it's media by name here, and even in the DSP file, we mapped it to media by name. And because the entity or the final landing zone entity was the same here, and because within the files, as you see, the placement names are the same between these two, it's simple. All it did was, this is the data stream, the data model made this as a constant. And for this constant, it was able to report the impressions between two of them. So that is what is happening over here. So you have the media by name, placement A, B, 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 C, 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 impressions and clicks, even though they're two different data streams. And this is the same principle we'll be using in the dashboard also, depending on how we are reporting. In the backend, you might think, okay, it's two different data sets, but at least in terms of visualization, they are the same, because you're use this common name as a principle. Now, if you want to see exactly how it's different, right, let me bring in media by key here. If you recall, I did say to you that media by keys are different, right? Now, if I do bring in media by keys, you'll know the exact extent of the blending. You see, there's one media by key which is impressions. There's another that is only clicks. There is one that is impression. There's another that's click. So at the media by level, you can say it's not blended because there were two different ones. But at the media by name, basically the placement level, it's blended properly. And to be frank, you actually never use media by keys for your reporting. You always extract the information coming in from the names, and that's how you report it, and that's how we achieve blending. And if you have to go extend, right, this this is an example I took for media by name, right? You can go far greater. Any of these dimensions across these Datorama and across all the data streams, right? Any of these dimensions that you see over here can be used for blending. So for example, even day can be used as a blending. In a simplified manner, you reporting on a daily level across multiple data sources is a form of blending. And if you want to bring in device level blending, you can do device category, even though completely different data sets. If they have device level data, you can still blend them. Same goes for geo level, campaign level, site level, creative, etc., etc. Because these are system dimensions, part of the data model that is defined by Datorama, right? By leveraging these defined data systems, we're able to passively blend. So the reason I'm trying to explicitly say this one is, not always will you find a situation where you'll need to put up a system to blend your data. Oftentimes, there's a simpler and effective method to do, and that's where passive blending comes. So that's where we are. So this is but one thing you would have noticed is passive blending is effective to the extent of the dimension which is common there. So here, the blending was happened between placement and placement because they were common one. Now, say you took this file, which is the right file that we created earlier from the previous session that has full length of the data. What if you try to passively blend this data with this data? If the placement names are common, blending can happen. Assume the placement names between the two files are common. The blending will happen, but it'll happen only extent of the placement names. So if you want wide range of data portability in terms of campaign level, site level data, you will not happen because the clicks you see is only for this placement. Suddenly you will not have this clicks for a campaign associated for this placement because that level of blending was not happen. That is where, I'll go to the next system that's called active blending. And in active blending, I'll take you through this process called parent-child relationship that you see over here. Parent-child, so if I can go to the use case also. So of course, you can go through these use cases. They have like a wide variety of different settings that you can use. For now, I'll give you an example of particular one use case. Now, let's close these two data sets because now we'll no longer be using them. And let's open a new data. Now, in this data set, what we are trying to achieve is, now a client says, no, see, I have two different data sets. Now, assume this is this. Now, in terms of use case, like try to visualize it this way. I assume this as an ad server data that has full set of hierarchy that has campaign, advertiser, placement, site, creative, etc., and its metric. Now, for this particular use case, what's happening is there's also publisher data that you're getting it in form of a child. What happens is sometimes within ad server, not all video metrics are calculated. Sometimes you rely on the numbers coming in from the publisher side, and then you integrate it within your data itself. Now, assume this is a publisher data that you got. Now, this client here is very specific. He says he wants full level harmonization. He wants this harmonization to go from campaign level to placement, advertiser, site, and also to creative level. In the previous passive level blending, we did it only at the placement level. And if you really want to cut the data at creative or site, you will not get it. But here the client is, he says he wants it at that level. Now let's see how we can use passive blending to get that level of, portability. With the important point that I'm giving you here, parent-child relationship, first and foremost, works on, entity relationships within the data model. And for that, it uses the keys for its connection. So the placement keys, the creative keys or campaign keys, etc., that is most important for the connection. Point number one. Point number two, if you recall the data model lesson that we did earlier, you'll notice for all the levels of the data, the main entity is always the media buyer. And that is what media buy is what is connected to campaign, and that is what is connected to site, and etc. and etc. So as long as the media buy level is properly defined, you can make sure the campaign, site, and anything about it, including the advertiser level, is properly captured. And using this information, we are able to do the parent-child relationship. And that's the reason we are having a defined media buy level data. Of course, since creative level data is many to many, and because the publisher is also willing to give this data, we can also make use of this connection in the parent-child relationship. And as a result, this file, the child file, can be fully integrated with the parent child over here. And there will be complete flow of information between both of them. And how to do that, I'll show you. Now let's go back to the data stream. Now, if you notice here, right, this, let's call this as the parent because it was already ingested. Let's not do it again. So this is the parent data stream. And for this, we will ingest the child data. So I'll create a new data stream. I'll pull in the child data and let's call this as child. And as I should give a preview, and it should ideally auto map everything for us. If as much as what it has able to find, and my hunch is the final metric wouldn't have been auto mapped. If not, we can map it. Okay, it has auto map, but it has mapped to something called as video views. But in our case, we want it as a separate view itself. So I'll unmap this one. I'll go to the custom metric over here and just select one that is free. Yeah, this should be good. So I'll take custom metric 2, click publisher view, change the name and apply. Perfect, done. So I'm just creating this data stream. Now so I did miss a step here. So instead of creating the data stream, I could have gone to the settings of the data stream and applied the child level information. So what I'll do is I can go back to this data stream.
Time check, we're 30 minutes.
Yeah, Ross, got it. Almost there. So I'm going to the advanced setting of this data stream for the child. And if you notice here, there is a parent-child relationship over here. I go here, I select the parent that I want to do, which is the right parent. These settings, you can go to the article. Of course, it's for this case, we'll just use this one and I'll just save it again. And it'll ask to reprocess the data, which I'll do. And done. And once this data stream is reprocessed, let's do a quick check over here. Perfect, it's done. So I'll now, if you notice, I'm clicking this data stream, going to the pivot. Just give me a moment. Yeah, so let's go to the pivot of this data stream. And yeah, so here's the thing. Now, if you recall within the file, right, this has only placement and creative level data. And the filter here is also only for the child. I'm not actually pulling in the parent. But now what I'll do is I'll just start pulling in advertiser name, campaign name. Let's also bring in site line and apply it. Don't have to bring in placement or creative level data because we know it's already there. But if you notice, the file actually doesn't have advertiser, campaign, or site. It's actually present in the parent child. But we were able to pull it here. If you notice, all the numbers are actually published against one. And if we go a bit beyond in terms of the date range, all this information should have been captured over here. So that is the power of parent-child relationship. What we essentially did was we made this parent that you see here and a child into a single bucket. And that's what you see here. For this child, you see the parent strain is this one. These are all in different entities, but in a sense, even though these are two different data streams, they're kind of like sharing a similar data model in the backend. They're kind of like formed a similar data table in the backend. And that is the reason you're able to, in the child data stream, you're able to bring in advertiser, campaign, site level data. So effectively what has happened was the use case has been done. The publisher data, even though you got it at the placement and creative level, you are effectively able to put it at the full level of the hierarchy. You're able to show this publisher data at campaign, placement, creative, site, and advertiser, which you see over here. And all this information is what is seen over here. Now, that is what is done in the parent-child relationship. So, so in terms of use case, right, parent-child relationship you can usually use, one thing is if you want like a neat harmonization between two different data sets, if you want like a full-fledged harmonization, you can use parent-child relationship. Of course, pros and cons, I'll come a bit later. Now I'll go to the data fusion and see like what then we can do with data fusion. In data fusion, let's, go a bit different. Now let's close this particular data set and let's open a different data set. Now in this file, right, data fusion, you can say this is kind of like, hybrid between passive blending and also active blending of parent-child relationship. What I mean by this one is by active blending, you still have to set up a process. But in terms of passive blending, you're leveraging Datorama's data model itself to do some of the harmonization for you. I'll give an example. In the previous passive blending, if you do a campaign level or the placement level, it's always strictly only at the placement level. In Fusion, what happens is depending on how the data is set up, right, you can go a bit hierarchy. So for example, even if you did the connection at the placement level, you can still leverage the campaign or the site level information that is above placement and get the data. So I'll start setting up the data fusion data stream. So I'll create new. So even for the data fusion data stream, we'll still use the parent as the one that is already set up. So I'll create a new one and call it as fusion. I'll bring in the file here. So important thing to understand is for data fusion to happen, the data streams cannot be the same model of the data. So what I mean, I'll let you know what I mean by that. It cannot be the ads model. It cannot be the existing model. You have to create a generic data stream. If you recall in the previous setup, I did explain about generic data stream, where you can define your own model and everything that is, in many to many. So in interest of time, so this is how you create it. You create click, you put a name here, and you can create a model, and that model would have been created. And that is what I've created here, and it's called as data fusion, which is already done. So for this particular thing, I'm going to use this model, and I'm going to continue with it. So day is already mapped. So let's map these ones also, entity keys also. So fusion entity key 1, I'll map it to placement ID, and name, I'll map it to name over here. And similarly, I'll take a custom metric over here. Oh, it's already there, which I named it earlier for testing purpose. I can map it here. That's it, done. So once everything is mapped over here, you can create the data stream. If you notice, it's only placement level data still. That's mapped in a different data stream, and you just name the fields separately because, I'll show you exactly. So once this one is done, and once this is, processed, what I will do next is I'll go to the dimensions. There's this option, and there's this nifty little thing, data fusion, that's already ready, available for you there. Here, you'll create add new. I'll just name it as, fusion demo. Here, first one, you'll select the media by name, because between these two data sets, the placement is the common key. And since placement, we mapped it as media by name in the parent stream. So I will call it as, media by name. I'll recall the media by name here. And now you will select the other dimension which you're linking this to, which in our case is the fusion dimension. If you notice, here you had like a lot of options, but here you're getting only the generic data stream options. And that's the reason I said you can't map between the same data stream, because you can't really map media by name and media by name. Right? Passive blending already takes care of it for you. So that's the reason you're doing it in a generic data stream. And you select this one here, and that's it, done. You save it. Usually it takes 5 to 10 minutes if you have a very large data sets for the fusion to happen. But my hope is with a shorter data strip, it should happen instantaneously. So I'll start creating a data stream. So let me refresh it once here. Okay, perfect. So I do have a fusion data stream over here. Okay, so let's create it again. Okay, perfect. So we do have it. So now what happens is, let's start building in a pivot out of this one. What I'll do is My hope is the fusion has happened and we will be able to get the data. But if not, I can theoretically explain you what has happened in the interest of time. So here I'll also be in, at least for the fusion, because it's not the same data set, you need to bring in the parent data stream also within the thing over here. And then let's start bringing in the values. So I'll bring in the placement name, which is the fusion name that we saw here. And now let's go be a bit adventurous. Let's bring in campaign name directly, which is coming in from the parent data stream. And let's bring in one of the impressions also from there, just so we see how far the blending has happened. Perfect. It is actually quite instantaneous. Let's increase the date range a bit to get a wider pull of the data. So once it loads, you will notice here, see, this dimension is coming in from the fusion data stream. This campaign name is coming from the parent. Because we mapped media by name to this one, this was effectively mapped to this one, and all the information is cross-flowing. Impressions is coming from the parent stream, but this metric fusion is now coming in from the fused file stream. Now that is the power of fusion. It's as simple. That's it, done. And you're able to leverage that information. Of course, it goes above because creative was not mentioned here. That level of fusion has still not happened, but placement, campaign, a site, which is anything that has many to one, that has happened over here. No, okay. So then you're seeing 3 levels of blending here, right? Now we are coming to the end of the session. Then how do you use which one? What is the thing? How which situation do you use which one? Let's simplify it, and let's take parent child and fusion over here. For my example, I'll give you most common reasons. If dashboard performance is a factor to you, and if you have relatively lesser number of data streams, and if you need full set of harmonization within the data stream, then I would say parent child is the way to go. But parent child has cons also in it. What I mean by that is, here we created one parent and one child, and we had to manually settle it. Now imagine you're an agency, you have like 100 different clients with you. You need to create hundreds of TCM, ad server data streams, APIs, and you also you have hundreds of publisher reports that's coming. Now in terms of scalability, it's difficult to manually go and map all of these financial relationships and reconcile them, process it and stuff. There it can become a con. Second also is, as I said, it should be within the data model itself. So if it's like a widely different data model, you can't really do parent-child relationship over there. So that's where fusion comes into the picture. With fusion, what you can do is, if large number of data, if you have a very large number of data streams where maintaining a parent-child relationship is a difficulty, you can do fusion. Because like I said, fusion, the advantage of fusion is it is leveraging Datorama's data model for you. Every single data stream, media by is being mapped. All you have to do is create a new data stream with a generic data stream. And as long as those dimensions are used across all the data streams, the fusion happens to you. I'll give an example. Parent-child is only between these 2 data streams, but fusion happens to every single data stream that has media by name and that has that another data dimension called a fusion key in it. So as long as these dimensions used across your data streams, you can do fusion. But what is a con for fusion, and why not be then if that's the case, everyone should use fusion, right? Why not? Why is it then not used? Is the problem is with the process. With parent-child data stream, each data is stored within the data table, and there's no live calculations that happen. And that's the reason I said, in terms of dashboard performance, the parent-child relationship is lighter and your dashboards are faster. But with fusion, the fusion happens in real time. So anytime a dashboard query happens, right, and if there's a query a dimension is a fused dimension, then it happens in real time. So if you have like very large data set, let's say 30 to 40 million rows, then dashboard performance does take a hit. So that's why you take a call. Now, having said that, right, and then you can do multiple of those use cases across multiple of the data streams. Excuse me. Yeah, sorry. So what I'm trying to say is all of this can be used across multiple of the data streams. Sorry, Ross, give me a moment.
No worries, Lohith. No worries at all, man. We'll give him a second. Lohith, why don't we try to we'll wrap things up. I think Lohith is sort of getting a drink of water and recomposing himself. It's all good, sir. Lohith expertly took us through 3 incredibly important aspects of Datorama. The first is around harmonization center. He demonstrated specifically uses of passive and active usage therein. Then he took us through parent-child relationships and walked us through that. And then ultimately, he introduced sort of really skilled and more advanced features as it relates to data fusion. So at this point, what we're going to do is we're going to compile all the worksheets, all the files, the webinars, and everything that we talked about during this webinar today, and have it posted on decisionfoundry.com/masteringdatorama. And we're already setting forward our next session, which is going to be scheduled sometime in early October. And this goes into a little bit different, deeper aspects of creating conventions and different relationships and the data. Custom classifications is what we're going to cover. So Lohith, I'll allow you to get that last few seconds to summarize, and we'll take it home.
Yeah, thank you, Russ. Yeah, so basically what I was trying to say was the way Datorama is set up is there's no restriction or nothing saying you that you shouldn't use a particular process. In the end, it comes down to how well you understood the data, what is a use case, and what is the most efficient way of getting the bang from the buck, like from your setup itself. From my personal experience, right, even though parent-child data fusion or custom classification, if you actually look into the data set, there's like a lot more. There's apart from these, there's also custom classification, which I think my friend will be covering in the coming session. And you can also use harmonization center. We do have multiple ways of doing it, and we'll be covering it. But the bottom line is, as a analyst, you need to take a call over here, which is the correct way of harmonizing the data, which is ultimately the best setup for you. From my personal experience, right, even though you'd have this active functionalities over here, try to ask a question. In most situations, 6 out of 10, I can bet saying that passive blending itself might solve the use case. If you're able to smartly leverage Datorama's backend model and architecture, right, seldom you might want to use parent-child on others. So what I'm trying to say is, try to see if passive itself is trying to solve your use case. In most of the times, that might be more than sufficient. And then go to the next one. Because as we go to, down the harmonization hole, right, it might become a bit technical. You might have to, be cognizant of a lot more factors. So that's where experience comes in, and that's where practice comes in. And that's the another reason why I'm saying session is one thing, but more important thing is you need to get your hands-on practical knowledge. You need to get you need to start creating your own data set, play with the data, go through the articles, and that's where you can master all of this one. So yeah, that's it, Ross. Thanks again.